Hi, my name is Dotan, and I'm a Microsoft Program Manager with the Machine Learning team, working on SQL Server R Services. And with me, I have Uma Chandar, who's also a Program Manager, and we're working together on the same team. We're pretty excited to be here today. Hey, Yussi.
Hi. I'm very excited to be here, and we are going to share the features of our services and what you can do with it.
Cool. So, SQL Server R Services, what is it? First of all, this is a new feature coming in SQL Server 2016. Beyond being just a new feature, it's actually kind of a cause for celebration to us, the product team, because it starts a new workload in SQL Server that is focused on advanced analytics. And a new workload is not something that is happening every day, so we're pumped up. Our services enables enterprise customers to embrace the very popular R language and combine it with in-database analytics. It's all about the ability to build predictive, smart, intelligent applications using R, and then not only being able to build it, but actually deploy it in a production environment in the enterprise. So R is great. It's a great language. It's a great ecosystem. It's open source. It's free. It has a great, huge community. But then when you actually wanting to embrace R in your enterprise, you're normally hitting certain challenges. And so our services is about addressing those challenges. Let's list a few of those challenges, the key ones that we are seeing with customers. So first of all, there is the data movement aspect. Currently, when you want to analyze data with R, you really have to move the data out of your database to a separate machine that is running the R runtime. Now, as the volumes of data grow, this becomes more and more complex because you have to set up workflows to move the data, because it would take time, because it has security risks. And so data movement becomes a real hassle when volumes grow. Second, there is the ability to call R from your application to place it in production. How do you actually do it? Is not trivial. To be able to operationalize, you sometimes have to recode your entire script in another language, which is not very convenient, and it takes time and is error prone. So this is a great challenge, actually. Finally, there's scale and performance. R is single-threaded. It can only accommodate data sets that fit into available memory, and so it's not really geared for larger data sets and big data. It would take compute time, and it would, you would run out of patience, I guess. And so those are some very, very, very significant challenges. But then again, our services is about addressing and solving those. So, Uma Chandar, can you tell us a bit about how our services solve these challenges?
Yeah, sure. Yeah, so with respect to data movement, the main thing we are doing is you can now push R scripts computation over to the SQL Server machine. So this eliminates data movement. So you don't have to pull large amounts of data over to the machine running the R scripts. And then how to use it in production very easily. SQL Server has T-SQL as the standard interface for applications. And by integrating R scripts into T-SQL, now you can use it in any application which is connecting to SQL Server. This allows you to use all the richness of the R scripts and return plots and rich data to your application. And lastly, with respect to performance and scale, you can now leverage all the SQL Server features like parallel processing, in-memory tables, column store indexes, and use that data along with your R scripts. So in this way, we've basically integrated R as a first-class citizen of T-SQL language. So this allows you to scale and use this in production very efficiently. Now we'll look at the key scenarios for our services. So it all starts with the data scientist. So this is the person who's working from R on his workstation and looking at data in the database. So we now have a very efficient way for the data scientist to do their data exploration. Then once the data scientist has done the exploration part and produced like a model and R script, so now they hand it off to the developer who can actually take that and put it in production. since we are using a familiar T-SQL interface, it's very easy to integrate these results from the R scripts into your application. And the results can be prediction information, very rich graphics, and plots from R scripts. And then the database administrator can also set up now policies and govern how the R scripts behave on SQL Server. So this way you can actually protect the critical resources on the database machine. And lastly, it's very easy for the data engineer to integrate workflows which use R scripts. So with these 4 scenarios, we basically cover an end-to-end kind of application infrastructure for SQL Server using R services. We'll now take a look at how to build an application using R services and SQL Server, and Dotan will explain about the fraud application.
Yes, thanks so much, Andar. So yeah, we're going to look at the use case that spans the data scientist and the developer, and it's going to be a fraud case, detecting fraud over invoice data. So we can look at the data set now that you would find in SQL Server. It's not a large one, it's like a 250K rows. And you could see that it has several columns, among them IDs for vendors. And on the right-hand side, you would see a column that has the amount for invoices. So each vendor submits several invoices, and we are tasked with identifying vendors that may be fraudulent according to the invoice amounts. So normally the data scientist would start by just exploring the data, right? So they would want to summarize the data, somehow look at statistics across this data set. The data scientist would normally work from their favorite IDE. And Umachandar, can you show us what will they do to get those summary statistics?
Sure, yeah. Let's take a look at how you can use this from RStudio. Okay, so what I have here is RStudio. This is one of the IDE which many data scientists use. And I have a script here which has many functions which start with the Rx. So these are functions which we provide out of the box with R services. So now here we are going to run this function called Rx summary. And this is similar to the R summary function. And the main difference is now you can set the compute context to SQL Server as shown here. And this allows the function call to be shipped to SQL Server, and you get the results back from SQL Server. So this eliminates the data movement challenge which we talked about earlier. And as you can see now, this returns results which look like the summary results from the standard R functions.
Perfect. So we've seen how the data scientists can actually get summary statistics on top of the data by pushing the compute to the SQL Server side. And now let's focus on the problem at hand, how to detect fraud. So as it turns out, there is this unique phenomena in nature that could help us solve this puzzle. It's called Benford's law. And as it turns out, this is a unique distribution that applies across a variety of things in nature and otherwise. For example, altitudes of cities and distances between stars and a bunch of other phenomena follow this special distribution. And as it turns out, invoice amounts also follow this distribution. So if we were to look at a specific vendor, we would expect their invoices to actually distribute this way, specifically looking at the leading digit of the invoice amount. Now, if we were to examine the leading digit of the amounts, and we would apply a standard statistical test, chi-square, and we were to find out that the distribution doesn't match the Benford law, we could assume that this vendor is suspected for fraud. And this is where R really shines, because with R, you can actually do these statistical manipulations and tests easily, whereas with standard SQL, it could take more time to implement it. So now the data scientists came up with this R line of code that you can see in the slide, and they want to somehow integrate it, somehow be able to call it from their application, run it, and return the results to the application. Umachandar, can you show us the magic of how it happens?
Sure. We'll start with the developer working from SSMS. What we have here is SQL Server Management Studio, and Now we'll show you how to use a new system stored procedure called SP execute external script to use R and T-SQL. So Dotan talked about the Benford law, which is used to detect fraud in these vendor transactions. So the data scientist essentially produces the piece of R script, which can now be invoked from T-SQL. And to that R script, you can pass data from a SQL query. So what we've done here is integrated a system stored procedure, which basically bridges R and T-SQL. So now if I run this, we actually invoke the R script, send the data from SQL Server to the R script, and then the R script returns the data for the vendors. And with that, I will show you how to integrate this stored procedure in a simple report. What I have here is the SQL Server report builder. This report will be used to list the vendors and flag each vendor to indicate if it's potentially a fraudulent vendor or not. So since the interface is a simple stored procedure, it's very easy to integrate with an application like report builder. So as you can see here, all I'm doing here is calling a SQL stored procedure, which actually invokes R. So now let's run this report. As you can see here, this report ran and returned a table which shows the vendors. And it also shows which vendor is potentially a fraudulent one. So what you see here on the light is a list of images for each vendor. This image shows the distribution of the invoice amounts with respect to Benford's law. So for example, in this case, the green is the expected distribution according to Benford's law. But then the actual distribution is very different, right? Like in this case, there are many invoices, like at least 90%, which start with the digit 2. So this potentially indicates fraud. So similarly, we have other vendors which are potentially flagged. And this basically shows how you can return graphics and images from R along with other results back to an application like Report Builder.
Great. So now that we've seen R services in action, let's take a brief moment to consider the logical architecture behind what we've seen. We talked about the data scientists working from their laptop, and they are basically writing a script and using what we call a compute context to indicate that they want the script to execute on the SQL Server machine rather than on their laptop. So they would push the compute. The execution would happen on the right-hand side in the SQL Server machine. And then finally, the results are returned to the laptop of the data scientist, and he will be able to view them like we've seen on the demo. The developer is calling from the application and having the execution happen through T-SQL stored procedures on the SQL Server, as we've seen. And again, the R script is embedded in this stored procedure, runs on the server side, and then results in the form of predictions, scores, plots are returned to the calling application. So that's the high-level logical architecture for the two use cases we have seen in the demo. So to summarize, we talked about SQL Server R Services being a new feature, an exciting feature in SQL Server 2016 that also starts a new workload. We've seen that it enables enterprise customers to really embrace the open source, popular R language, and then not only embrace it, but actually be able to deploy it in a production mode in a secure fashion that fits enterprise. And with that, we conclude this session. We hope you have enjoyed it, and thank you for your time. On behalf of the product team, we're pretty excited to have this feature launched and in the market and in your hands. So yeah, let us know what you think.
Thank you very much for watching the video. Hope you learned something about the R services, and let us know if you have any feedback and how you used R to build better intelligent applications.